Okay, our first problem is going to be problem similar to number 45, where we're trying to find the value of a function like f of negative 3 given a certain function. It says use a remainder theorem and synthetic division. So just to kind of reinforce this, what I'm going to do is I'm going to go old school, and up here at the top I'm going to find f of negative 3 by just taking 2 times negative 3 cubed minus 7 times negative 3 plus 3. Okay. Negative 3 cubed is negative 27 times 2 is negative 54 plus 21 plus 3. So that's negative 33 plus 3, I believe is negative 30. We're going to test my math here in just a second. Okay, so basically my y value when x is negative 3, it should be negative 30. Remainder theorem says that if you use synthetic division with that function and use the value x equal negative 3, the remainder will be that y value. So our remainder should be negative 30 in this case. So if you wanted to find a y value, I can very simply go 2 for x cubed, 0x squared, negative 7x, and 3. I can drop that down. Yes, I did it again. Multiply negative 6, add negative 6, multiply 18, add, let's see, 11, multiply negative 33, add negative 30, and bingo, ladies and gentlemen, I have the y value right there, which is a whole lot better and more legible than my scratch up there in the corner. That is it. That's all you do to find f of a value of f, using synthetic division. Okay, our next problem, I'm going to look at the set for number 47. The directions say use synthetic division to show x is a solution, so that means it should divide out evenly. Notice it's not given f of x, is given the equation, basically f of x equals 0. So we're going to verify using synthetic division and then use a result to factor it. Okay, so it says list all the real solutions. Notice it doesn't want imaginaries, but we could do the same thing with imaginaries. So they're telling me x equal 4 is a solution to this. So to verify that, I'm going to use synthetic division. I'm going to put x equal 4 outside. I'm going to have 1x cubed, 0x squared minus 13x minus 12. I'm going to drop that down. Yes, I'm going to multiply. I'm going to add, I'm going to multiply, I'm going to add, I'm going to multiply, and I'm going to add, and I get 0. Remainder theorem, like our last problem, tells me the y value is 0 when x is 4. Okay? So, here's the key. They want us to find the others by factoring. So, this was x cubed. I took out an x, I'm down to x squared, and x, and then a constant. So this is x squared plus 4x plus 3. Now, I could use quadratic formula. It does say use the result to factor. So I'm now going to make this a little smaller. And I'm going to factor this leftover, setting it equal to 0. I'm going to have x and x, 3 and 1, positive and positive. That will give me x squared plus 4x plus 3. That would give me x equal negative 1 for a solution and x equal negative 3 as a solution. So to kind of carry into where we're going next, let's connect those real quick. I'm going to say if our zeros from synthetic division, from a graph, etc., are x equal 4, x equal negative 1, and x equal negative 3, if those are zeros of my original function, then I can factor that function by turning these back into factors. If I subtract 4 from both sides, I'll have x minus 4 as a factor. So x minus 4 equals 0, give me x equal 4. Similarly, take that 1 to the other side, I'd have x plus 1 as a factor, and x plus 3 as a factor. So that is the linear factorization of the original function, x cubed minus 13x minus 12, which is ultimately going to be our end goal.